Hello class, today we're looking at 5.4 solutions and applications of right triangles. Historical backgrounds, significant digits, solving triangles, angles of elevation and depression, bearings, and other applications. So first thing we're looking at is significant digits. A significant digit is a digit that obtained by actual measurement. The significant digits in the following numbers are identified by being underlined. So if I had 408, all numbers are significant. If I have 21.5, all numbers are significant. If I have 18.00, all those numbers are significant. If I have 6.700, all those numbers are significant. If I got 0.0025, the only numbers that are significant is 25. If I have 0.09810, the only numbers of that is 9810 that are significant. If I have 7300, the only two numbers are significant is the 7 and the 3. Your answer is no more accurate than the least accurate number in your calculation. So make sure that you understand what is significant, what's not significant. If you notice, the only numbers that are not really significant are what? Zeros. All right? So the thing is, not all zeros are insignificant. It just depends on where it is at. All right? So keep that in mind. So if we think about significant digits for angles, if we look at degrees, like 62 degrees or 36 degrees, that'd be two significant digits. Let's say if we had 52 degrees in 30 minutes, that is what? Three significant digits. The zero is not significant. Let's say if we have what? 81 degrees, 48 minutes. We have four significant digits. Or let's say we have 10 degrees, 52 minutes, and 20 seconds. That means that we only have five significant digits. So just make sure when you look at this, you follow these charts so you can know exactly what you're actually using. So solving right triangles. To solve a right triangle or solve a triangle means to find the measurements of all angles and sides of a triangle. When solving triangles, a labeled sketch is an important aid. Now, all your problems won't give you a sketch, so you have to make the sketch yourself. Use A to represent the length of the side opposite to the angle of A, and use B, little b, as the length for the side opposite of the big angle B, and so on. So just like we use C for the hypotenuse. All right, so keep that in mind. Now, let's say we solve this. They gave us a few things. So they gave us A is equal to 34 degrees and 30 minutes. And then they gave us C is equal to 12.7. Now, what we could do, we can find other angles or other sides. So if I have the sine of A is equal to what? A over C. Now we have the sine of 34 degrees and 30 minutes is equal to A over 12.7. Therefore, A is just equal to 12.7 times the sine of 34 degrees and 30 minutes. Now, make sure your calculator is in degree mode. Put down your calculator, you should roughly get 7.19. And you know that the units would be inches. Now, the same way, we're going to use cosine of A, which that's equal to what? B over C, which that is what? That'd be B over 12.7. So we got what? We got cosine of 34 degrees in 30 minutes is equal to B over 12.7. So basically, B is just equal to 12.7 times the cosine of 34 degrees in 30 minutes. So when we put that in the calculator, we get what? Roughly 10.5 inches. Now, but we still have one unknown. We need to find B. So B is just equal to, now, all the angles in a triangle add up to be 90 degrees. So if I were to take, we already know that C is 90. So if I were to say 90 minus my 34 degrees in 30 minutes. Now, remember, you can rewrite this as 89 degrees and 60 minutes. So you can easily do what? The subtraction. So B is just equal to 55 degrees and 30 minutes. These are all our unknowns that we needed. And if you notice, all of them have what? 3 significant digits. All right, so keep that in mind. So let's look at this one. It says solve the right triangle ABC. I got A, little a, which is the side, equal to 29.43. And we have little c is equal to 53.58. Now, we could do this a couple of ways. We could say I got the sine of A is equal to, and I'm going to do opposite, which is 29.43, over hypotenuse, which is 53.58. Then I'm going to take the sine inverse of it. So I'm going to have A is equal to the sine inverse of the 29.43 over 53.58. Now, it's important that you don't round before you do all this because it will skew your answers. So A is just equal to roughly around about 33.32 degrees. All right? So keep that in mind. Now, let's just say if we wanted to make sure, if we wanted to look and see if it was, now let's say if they wanted it, or you can actually have this as what? 33 degrees in 19 minutes. So, but it's a what? It's an approximation, right? So what about B? You can find big B by saying 90 minus the 33 degrees in 19 minutes. Now, in your questions, they'll tell you specifically if they want decimal form or if they want degrees minutes form. So B is just equal to roughly 56 degrees and 41 minutes. All right, so now let's find side B. So now remember, the Pythagorean identity was what? A squared plus B squared is equal to C squared. Now I'm gonna just use what? B squared is equal to C squared minus A squared. So I got B is equal to the square root of 53.58 squared minus my 29.43 squared. So B is just equal to roughly 44.77 centimeters, because that's what we are in centimeters. Now, make sure if you have any questions about this, you send me a message through Microsoft Teams or you send me an email. So keep that in mind. So, talking about angle of elevation, angle of depression. Now, the way you want to look at this, they both are the same, all right? But one is what? Elevating, one is what? One is depressing. So, let's look at what we have. The angle of elevation is the point X to Y. X, so above X is an acute angle. And the same for the angle depression, which is going to be what? A point from X to Y below X. So when we look at these, now these are considered alternate interior angles. If you remember anything from your different geometry classes or whatever else you talked about, or angles or whatever else, you talked about alternate interior angles. So basically the angle of depression is what? Equal to the angle of elevation when we're dealing with this. So let's look. So it says a point A is 123 degrees, 123 feet from the base of the flagpole. All right, it said the angle of elevation to the top of the pole is 26 degrees and 40 minutes. Find the height of the flagpole. So let's look at this. So when we look at this, we have the opposite side. We don't have the opposite side. We're looking for the opposite side, which is A. And we have the adjacent side. So I'm going to use the tangent of 26 degrees and 40 minutes. And I'm going to say this is equal to A over 123 feet. All right. Now, A should be just equal to 123 times the tangent of 26 degrees and 40 minutes. So A is equal to, put that in the calculator. It's roughly around about 61.8 feet. And I use 61.8 because what? It's 3 significant digits, and it's 3 significant digits in my for my feet, for my lengths. All right, so keep that in mind. So once you get used to using the trig functions, or these trig functions, or looking at the triangles to actually use them. So once you do it multiple times, you will get used to using it. So you'll know if one is opposite over adjacent or adjacent over opposite or stuff of that nature. So let's look at this one. It says from the top of the cliff is 210 feet, top of the 210 feet cliff. David observes a lighthouse that is 430 feet offshore. All right. It says the angle of depression from the top of the cliff, all right, from the base of the lighthouse. So we're trying to find the angle of depression. Now, we could do this a couple ways, right? So if we're looking for the angle of depression, it should be the same as the angle of elevation, which this will be the angle of elevation. All right. Therefore, I can say I have the sine, well, not sine, sorry. I have the tangent of B is equal to 210 over what? 430. So B is just equal to the tan inverse of 210 over 430. So B is just equal to what? 26 degrees. So therefore, A is equal to, or the angle of depression of A. So the angle of depression is what? 26 degrees. All right? Because these are what? Alternate interior angles. So they are equal to each other. So just keep that in mind. So let's look at this. Bearings. There are two models expressing bearings. When a single angle is given, such as 168, it is understood that the bearing is measured in clockwise direction due north. All right? So like on the first one, if we had a straight north pole, we move to the what? To the right, 32 degrees. Same in the next one, we move to the right, 164 degrees. So we're looking in a clockwise matter. So let's look at this right here. Now, it says a radio station A, all right, and B are east-west line at 3.7 kilometers apart, or kilometers, however you want to say it. So let's look at something. So my first thought would be to draw 2 points and then connect them. And this is 3.7 kilometers, right? Now, they give us that, right? And let's say that this is A, and this is what? B, right? Now, it says what? Station A, so Station A detects a plane at C with a bearing of what? 61 degrees. So, me personally, I like to go ahead and put that's north, that's south, right? Now, it says that it has a bearing of 61. So therefore, we have a bearing of 61. So therefore, I have something like this. And this is 61 degrees. All right, let's work this out. Now, and I'll use a different color. If we draw our poles from here, which this is north and this is south, all right, it tells us that we have, it says Station B simultaneously detects the same plane with the bearing of 331. So we know if we start here, we know here from here is what? 180. Then we got 270. And then we go a little bit further, we have what? 330. 331, right? So 331 degrees. All right? Because we moved in a clockwise formation. Now, this is a rough draft, of course. Now, this, where C is at, is a right triangle. All right? Right triangle. Now, this is not drawn to sketch, but it's just a rough draft for what we're doing. Now, also what we have to understand is, since this is 61, this would be 61. which could have found that easily because of, when we did our sketch, we had to go 61 more, all right, to get to 331 from 270, right? So let's keep looking. So we actually want to find the distance from A to C. So now, from A to C, so we actually could look at, we know that this would be 29 degrees, right? So we'll do the cosine of 29 degrees is equal to adjacent, right, which is your adjacent side would be your B, over your hypotenuse, which is your 3.7, all right? So remember, opposite, this is B, and this is your C, and this is your A. So basically, B is equal to 3.7 times the cosine of 29 degrees. So B is just equal to what, roughly? 3.2 kilometers or kilometers. That's roughly. And that's what we was trying to find. So just make sure when you're sketching this, you kind of think about what it's actually asking you to do. It makes it a lot better if you sketch it. So let's look at a second method expressing bearings. So it says it starts with north-south, all right, line, using the acute angle shown in the direction, either east-west from the line. So if I'm going northwest or northeast, I'm going to be going clockwise. If I'm going south, east, and you got to look at the direction as well. All right? If it's going up, down. Now, if it's going south, we know it's going downward. All right? But and if I got southeast, I'm going what? Counterclockwise. If I have southwest, I'm going clockwise, but I'm going down. And if I got northwest, I'm going what? Counterclockwise. All right? And I'm still going up. All right? So keep that in mind. So look at these angles, because think about when you're actually drawing these, you got to kind of draw what direction is actually telling you which way to go. So let's look at something. It says, all right, it says a ship leaves a port and sails on a bearing north 47 degrees east. All right. Now, for 3.5 hours, it then turns and sails on a bearing of south 43 degrees east. All right, at 4 hours. It says if the ship's rate is at 22 knots, nautical miles per hour, find the distance from that ship and its port. So let's look at this. Let's say the port that we started at is A, or this port right here. Now, me personally, like I said, I like to go ahead and draw my north and my south. That's my starting point. Now, I know it said I was what? 47 degrees east. So I'm going this direction. All right? So it's 47 degrees. All right? $47 degrees east. So we have to make sure. Then it says it does what? Turns. So now I'm going to make another north and south. And this says it turns what? South 43 degrees. So I have to go from here to here, which this would be 43 degrees. All right. Now we know that we're actually can go ahead and connect these two. Now, honestly, we know that if this is 43, this is what? 47. All right. Because this is going to be our what? Right angle. All right. So let's look at what we have. So what we need to do now is we need to figure out what we have. So we know we was going northeast at 3.5. So we have to do 3.5 hours. Then we multiply it times by 22 nautical miles. And you know that was per 1 hour. Which my hours go away, which is my time, and I just multiply the two together, then I should get what? 77 miles. All right? Or nautical miles. Let me go ahead and put the nautical miles. And I'm going to do the same thing with the other one. I'm going to get 4.0 hours. And I'm going to multiply it times my 22 nautical miles per hour. And what happens is the unit goes away. That's what I'm doing there. Therefore, when I do that math, it should give me what? 88 miles. And that just gives me the distance. So what I'm going to do is just go ahead and label this. So my first one was what? 77. And I'm going to just put miles. And then the other one was 88. Now, these are nautical miles. I just put miles just because that's nautical miles. Now, we're trying to find how far it went at the bottom, right? We're trying to find what the length that it went down at the bottom. Now, that's easy because all we got to do now is do what? We have two sides, right? So we're basically trying to find the hypotenuse. So we're going to use a squared plus b squared is equal to what? C squared. Therefore, we're going to have what? 88 squared plus 77 squared is equal to c squared. So we know that c is just equal to the square root of the 88 squared plus the what? 77 squared. So c is just equal to roughly 120 nautical miles. So make sure you put that in your calculator so you can check your answer. Make sure if you have any questions about this, you make sure you contact me. So let's look at this problem right here. Now, I personally like this problem. All right. It says Francisco needs to know the height of a tree given the point on the ground. He finds an angle of elevation to the top of the tree is 36.7 degrees. He then moves 50 feet from the second point. The angle of elevation of the top of the tree is what? 22.2 degrees. Find the height of the tree to the nearest foot. So we have two things here. We have two, if you notice, we have two triangles. We got the big triangle, we have a smaller triangle. We actually have three triangles if you think about it, because we got the smaller one, and we got the slanted one, and we got the other one. So let's look at what we have. So, me personally, let's look at one. Let's see. So if we got the tangent of 36.7 degrees is equal to h over x. And that's for this one right here. All right? That's for that one. Which that means that we have h is equal to what? X times the tangent of 36.7 degrees. You're like, okay, it's nothing we can do with that. I know. So we have to do a little bit more work. So in red, I'm about to put, we have what? The tangent of 22.2 degrees. And we're going to say that this is equal to h over 50 plus x. Because we're doing all of this. All right? So if we have to do 50 plus what we have for x. So in this case, h would just equal what? 50 plus x times your tangent of 22 degrees. All right, you still sticking with me so far? All right, so now I have two h's, right? So now I can go ahead and set equal those two things, this and this, because h equals both. So basically I have x tangent of 36 degrees, 36.7 degrees, is equal to 50 plus x times the tangent of 22.2 degrees. So what I'm going to do is I'm going to go ahead and do what? I'm going to go ahead and do my math. So this is just x times tangent of 36.7 degrees is equal to 50 times the tangent of 22.2 degrees plus x times the tangent of 22.2 degrees. All right? And let me go ahead and fix this real quick. That's just a 2. All right? So now I'm going to put all the x terms on the same side. So I'm going to have x tangent of 36.7 degrees minus x tangent of 22.2 degrees is equal to 50 times the tangent of 22.2 degrees. So now I'm just going to factor out an x. So that's going to be x times the tangent of 36.7 degrees minus tangent of 22.2 degrees. And that's equal to that 50 tangent of 22.2 degrees. So basically x is just equal to 50 tangent of 22.2 degrees all over the tangent of 36.7 degrees minus the tangent of 22.2 degrees. Now, when you do this problem, you just got to make sure that you keep your order correct. Now, me personally, I keep it like this, because all we need to do is find what x was. All right? And now we can just plug it into any one of these equations. I would say plug it into the easiest one, which is this one. So this is H is equal to, and this is the 50 tangent of 22.2 degrees all over your tangent of 36.7 degrees minus the tangent of 22.2 degrees. And then that'll just be, we'll have all that times your tangent of 36.7 degrees. Now, moving up to the top, so H is just equal to what? Roughly 45. So when you put it in the calculator, you should get roughly 45 feet. So make sure if you have any questions about this, you send me a message and let me know what, any issues that you have with this problem.